In this video, we are determining the domain of two functions. So let's start with g of x is equal to the square root of 8 minus 3x divided by 2x plus 1. So let's start with the numerator. We'll notice that we have a square root in the numerator, and we do have some restrictions for square roots. We cannot have a negative number inside of a square root because that will be a non-real answer. So what's inside the square root here can't be negative. Now it's also important to ask yourself if 0 is okay. So you might ponder, is it okay to take the square root of 0? And the answer there is absolutely yes. The square root of 0 is just 0. So it's okay to have 0 inside of a square root, or a positive number. In this case, it's only a negative number that is not going to be okay. So that means what's inside our square root, which is 8 minus 3x, it must be greater than or equal to 0. It has to be bigger or equal to 0. So we have an equation here to solve, not an equation, an inequality, and it is a linear inequality, so we'll just subtract 8 from both sides and divide by negative 3. Remember, when you multiply or divide by a negative number in an inequality, the inequality symbol flips. So that is going to turn into a less than or equal to, and we'll end up with 8/3 on the right-hand side. So x is less than or equal to 8/3. This is the first part of our domain. Now the second part comes from the denominator. We need to ask ourselves, are there any restrictions in the denominator? In this case, we know we cannot have 0 in the denominator of a fraction. So that means our denominator, 2x plus 1, cannot equal 0. And we need to solve to figure out what value of x will cause this denominator to equal 0. So we'll subtract 1 from both sides and divide by 2, which gives us that x cannot equal negative 1/2. So we have two sets of restrictions. X cannot equal negative 1/2, and x must be less than or equal to 8/3. And we want to write all of those possible values as an interval. So I recommend that you draw this on the number line first to help you write this in interval notation. So if we were to have negative 1/2 here, x cannot equal negative 1/2. So I'm going to put a kind of an open circle there to indicate that I cannot have negative 1/2. And 8/3 would be over here somewhere. And x must be less than or equal to 8/3. So that means x could be any number smaller than 8/3, but we're going to skip over negative 1/2. It cannot equal negative 1/2. It could be any number smaller than negative 1/2. And then because of the equal to, less than or equal to, that means 8/3 is okay. So you could either draw a solid dot to indicate that 8/3 is included, or you could use a bracket to indicate that 8/3 is included. I like the bracket because that helps you write your answer for the domain in interval notation. So there are two intervals here, from negative infinity to negative 1/2. Then we would use a parenthesis to indicate that negative 1/2 is not included in the domain, and we will union that with the interval from negative 1/2 to positive 8/3 with a bracket to indicate that 8/3 is allowed, or it is included as a domain value. And this would be my domain of that function. Moving on to the second function, f of x is equal to the natural log of x squared minus 4. We have restrictions inside of logarithms. So it's important to remember that we cannot take the log of 0, and we also cannot take the log of a negative number. So what's inside the logarithm, which is what we call the argument cannot be 0, and it also cannot be negative. So this means the quantity x squared minus 4, if it can't be 0 and it can't be negative, it must be greater than 0. It must be a positive number. So very similar, if I go back to the previous problem, it's very similar to what we did here with the 8 minus 3x. We said, oh, it can't be negative. But for a square root, remember, we said it was okay to take the square root of 0. So that's why we included 0 here, greater than or equal to 0, when we worked on the domain. But back to our example, we cannot have 0 in the argument of a logarithm, so we do not want to include 0. So now we have x squared minus 4 is greater than 0. Now this is a quadratic inequality. It's not linear. So I'm going to choose to factor. In this case, x squared minus 4 is the difference of perfect squares. And the reason I'm factoring this is so that I can determine the zeros. So I know that negative 2 and positive 2 are the zeros. In other words, if I substituted in negative 2 or positive 2 for x, I would get a value of 0. And since I want values greater than 0, then I'm going to test around negative 2 and 2 to determine which intervals will give me a positive number greater than 0. So you could do that physically by actually testing values, choosing a number smaller than negative 2, let's say like negative 3, a number between negative 2 and 2 like 0, and a number greater than 2 like 3. And we could actually take these test values and we could test them into x squared minus 4 to see whether they give us positives or negatives. But I believe that most of you probably have an idea graphically of what x squared minus 4 looks like as a graph. So I imagine many of you are familiar with the shape being a parabola, and in this case it's a parabola that opens up. So if negative 2 and positive 2 are the zeros, that means those would be the x-intercepts, and our parabola would look something like this. So if we are interested in finding the portion that is greater than 0, that's like asking for the portion of the parabola that is above the x-axis. And there are two pieces of this parabola that lie above the x-axis. So that's going to tell us that our domain values will be all the values here to the left of negative 2, smaller than negative 2, and all the values to the right of positive 2. And then because it was greater than, not equal to, it was just simply greater than 0, we would not want to include negative 2 or positive 2 in our domain. So our domain will have two intervals. The first interval is from negative infinity to negative 2 with a parenthesis, and our second interval is from 2 to positive infinity for our domain values.